Good day, good morning, afternoon, night, depending on when you're watching. Welcome back to my channel. So in the previous class, we treated, as you can see here, dealt with the rules for the use of logarithms. I emphasized on multiplication, division, power, and roots. We had some examples worked out. Then I gave you some exercises, as you can see here. Now I said when we come back, we'll deal with logarithm of a number less than 1. So let's go for that. We have this. Normally, when we say a number is less than 1, what we are saying in essence is that we're talking about a number like 0 point something. Numbers less than 1 usually start with 0. So we have one of them here, 0.07896. How do we write it in standard form? Well, the rule remains the same, whether it is less than 1 or greater than 1. The decimal point comes immediately after the first significant figure or digit, that is to say, the first non-zero digit. In this case, it happens to be 7, the first one that appears. So we are moving the decimal point into places 1, 2. From this place, 1, 2. So we have 7.896 times 10 to the power of minus 2. Remember, there is always minus for numbers that are less than 1. The power always have a negative sign. That is a standard form, and then it is the same thing as this. We have 10 to the power of 0.8974. What we are saying in essence is the logarithm of this is this. If you have to express this in form of its log, or simply put, if you have to express 7.896 in terms of base 10, you get that? Either in form of its log or in terms of base 10. This is how to be expressed. I guess you know how to do that. You look for the logarithm of a number whose logarithm is corresponding to this. So you have this 10 to the power of 0.8974, then times 10 to the power of minus 2. Now this is indices. Just pick one of the base since they are the same. Because in indices, if you have something like this, s power of 1 times s power of 2, since the base is the same, just pick the base out of the powers. If we have y raised to the power of 3 times y raised to the power of 4, just pick the base and add up the powers, and that's y raised to the power of 7. In this case, this is s to the power of 3. So this is logarithm indices. We are using the logic here now. This is 10 to the power of minus 2 plus this, or you can say this plus minus 2. Whichever one you want to come first. And that means you can say that the logarithm of this, the logarithm of 0.07896 is equal to, remember the logarithm refers to the power of base 10. I hope you know. So that means you can say the logarithm of this is equal to this, that is minus 2, plus 0.8974, talking about the powers of the base 10. Here in power of 10, the characteristic is what? We have minus 2, and the mantissa is this other side, 8974. We add up the characteristics to get the final result. Minus 2 plus 0 is minus 2. So the characteristic is minus 2. The room answer is 8974, the one at the right hand side. Now, but it is take note of how it is written. We added up just the characteristic aspect -2 plus 0, giving us -2 or bar 2. It's better you say bar 2 point than the answer. So take notes. A note is written here that you can see that bar 2.8974 is the same thing as -2 plus 0.8974. And bar -2.8974 is equal to -2 plus -0. Blah, blah. You can see what is written there. So just take note of this fact. You see the differences, right? If it is bar 2, see what you have. But if it is -2, there are differences. So you see it. Now let's see this example. Use the tables to find the logarithms of this and this. Now, how do we use tables to find the logarithms of these numbers? Similar to what we have been doing before. As for the first one, how many zeros do we have here? 2 zeros, right? After the decimal point, you add 1 to it, making 3. If you are looking for the logarithms. Or otherwise, you have a 0.005608, right? How many zeros in total? There are 3, both at the left hand side of the decimal point and at the right hand side. Put together, there are 3. So you have 5.608 times 10 raised to the power of -3. Why -3? You see this. If you have to move it to this place, 1, 2, 3. You see the logic? That is one way. So that is 5 points. That is if the point is to be moved here. 5.608 times 10 is the power of how many times? 3 times. -3. Remember, this number is less than 1. So the bar, mean the power must possess negative sign. So the characteristic is bar 3. See how it is written, bar 3, minus sign at the top of the number. So, among the videos that we uploaded, this is where we stopped the last time. So, we'll continue from here now. Now, to find the answer, we do what I have been doing before. What do we do? I'm talking about the decimal parts now. To find the answer, in the logarithm tables, you look for 56 under 0. You know how I will be doing it. When you look for 56 under the column headed 0, so you obtain 7482. I will not go there, but this is what we obtain. If you get a logarithm table, you will see that. And then continue across until under column headed 8 in the different parts. You know what I mean? You will find 6, right? And when you add it together, you obtain 7488. Hence, you can say therefore, this is the sign for therefore. Therefore, the logarithm of 0.005608 is equal to about 3.7488. That becomes our final answer. You get that? Now let's take another one here. Let's go for B. I have the logarithm of 0.00049688. Now let's go. We have to use the table to find the logarithm of these numbers. If you watch this, how many zeros do we have here? 3, right? So I have 3 zeros. And that implies that 3 plus 1 is equal to 4, right? or you can say 0.000498 is equal to 4.968 times 10 to the power of minus what? If you move this point to this place, 1, 2, 3, 4, then minus 4. How did I know it's supposed to carry minus sign? Since this number is less than 1, I already know it's minus sign that it will carry. Or since I'm moving the decimal point to the right hand side, I already know this is going to be minus. See that? So since the decimal point, I'm moving it to the right, I know it's going to be minus this power. Or simply say that since the number is less than 1, I know the power must be having a negative sign. How do you know that the number is less than 1? You see 0 starting it. Right? So we have the characteristic should be what? If we have 4.968 times 10 raised to the power of minus 4, the characteristic is bar 4. Right? That is the integer part. It is bar 4. Now that we have bar 4, let's say therefore the characteristic is bar 4. That is what it is. Now, then we use the logarithm table to obtain the mantissa as described in the first part. You know how to do it. 49 under 6 difference under 8. You get your mantissa. You get that. You know how to do that now. You know how to look for 49. Now to look for 49 under 6 and difference under 8. So by the time you do that, you get your mantissa and you say therefore the logarithm of 0.000496 is equal to bar 4.6962. How did we get the 6962? Maybe I should take you back to the logarithm table. Even though we have done justice to this time without number, we say that you look for 49 under 6, difference under 8. Just in case you know use a calculator. You're a nice person, use calculator here. Let's see. 49 under 6, difference under 8. What do we have? You have to check 49 under 6. You have 6955. Now difference under 8 is 7. You know it must be added. That will be what? 6962, right? That is how we got the mantissa. And the characteristics, you know the characteristic is minus 4. You know how we got it. The characteristic is written by 4. So I just decided to go back there just in case you are lost or you have forgotten or you've not watched the previous videos, right? Good. So we can be on the same page. Now, let's take more examples. Call them other examples. Other examples. Other examples. It says use anti-log tables to find the numbers whose logarithms are A. We have bar 2.7903. B. We have bar 4.0907. So look for the answers of this. Our solution. A. If you are to find the antilog of bar 2.7903, what's the mantissa? Notice that the mantissa is equal to what? 0.7903. What am I calling the mantissa now? This right hand side. Right? 0.7903, or you can call it 0.7903. So this 0.7903 in the log table is equal to 0.6170. You know what I mean? What I mean is, the question says use anti-log table to find the numbers whose logarithms are. So this is the logarithm. You are looking for the anti-log. So if you go to the log table, find a number that is corresponding to this logarithm, you will see that you will find it under 61, under 7, different 0. That is what it means. So if you don't know how to do this, just visit the previous videos. So we have 0.6170. Now the characteristic is what? Bar 2. So it's bar 2, right? Now this means that there must be 1 0 between the decimal point and the first significant figure. So therefore, the antilog bar 2.7903 is equal to 0.06170. Now, in case it is not clear to you, you want more clarity regarding this aspect, remember that the characteristic is bar 2, right? And since the characteristic is bar 2, what does that mean? There must be 1 0 between the decimal point and the first significant figure. Remember when we have bar 2, it shows that there are 2 zeros before the first non-zero digit. That's the first significant figure. As it means bar 3, it means we have 3 zeros. If it's bar 4, we have 4 zeros. If it's bar 1, we have 1 0. So if it's bar 2, obviously we have 2 zeros before the non-zero or significant digits. Or you can say that it means after the decimal point, there must be another 0 before the 6. That's the non-zero digit there. Do you understand the logic now? So it is that simple. Now, let's take the second example. We have the antilog. We have to get the antilog of bar 4.0907. What's the mantissa? The mantissa, as this other part, is 0.0907, right? And so we can say that 0.0907 in the antilog table is what? In the antilog table corresponds with 0.1232. You know what that means? That is to say that if you go to the logarithm table and look for the numbers whose logarithm is corresponding to this, what you will get, you will notice that you will find this, for you to get this, that will be 12 on that 3 difference too. That is what will give you this. You understand that? Go to the previous video for you to understand this properly, just in case you do not understand this. Now, if you have this, remember that the characteristics is what? The characteristic is bar 4. This means there must be 3 zeros between the decimal point and the first significant figure. So therefore, the antilog of bar 4.0907 is equal to 0.000123. See that? It is as simple as that. Just in case you are lost, let me repeat this part. You know the characteristic is bar 4. And you don't get the characteristics from here. Bar 4.0907. So now that I've been able to get this, and I know that the characteristic is bar 4, it means there will be 4 zeros before the first significant digit or figure. So we have 4 zeros. And of course, you know that immediately after the first zero, the decimal point has to show up. That means we have just 3 zeros after the decimal figure before the significant figure. It's simple, right? If you have questions, you can feel free to ask a question in the comment section. I will likely respond to your questions as far as the sake of clarity is concerned. Now you have some exercises here. I'll give you some exercises that we have in our book here. Attempt this. We have question 1. Write down the characteristics. That is to say, the integers of the logarithms of the following numbers. Give you some of them here. I have 0.567. We have 0.00708. We have 0.0000386. Let me give you out of 5. We have 0.09. Yeah, let's stop there. Question 2. Use tables. Try as much as you can among these exercises to find the logarithms of the numbers in question 1 above. In question 1, that's the question 1 above that we mentioned. So, question number 3. Let me give you the third one. Use anti-log tables to find the numbers whose logarithms are A by 1.4905, B by 3.6781, C by 2.0907, D by 3.5711. So we'll stop here. When next will come, as for the next clip, we'll treat this. Go for multiplication as our next subtopic. Multiplication and division of numbers less than 1. So we'll go for the multiplication and division of numbers less than 1. Still dealing with logarithms. And after we have done justice to this, we can go ahead and head for the next topic, which will be dealing with approximation and accuracy. So have a blessed day. Thank you for watching. Please do well to subscribe, and I appreciate very much. Thank you very, very much for watching.